Hi, today we are going to talk about sets. So by a set in mathematics we understand a collection of elements, and elements can be absolutely anything. So I have some examples of what sets could be. This is 3 winter months here. Please note that we use curly braces to indicate that we're dealing with a set, this and this. Some military ranks for set B. There's the grades A, B, C, D, F. There's just an airplane as a method of travel. You can make your own set by listing the names of your closest family members. In mathematics we often deal with numbers, although not always. So here's some more examples of sets. Set F, 1, 2, 3, 4, 5. Set G, we sometimes use 3 dots when the set is kind of long and we don't want to list every single element, because like this one's kind of short. But here you're going to have to go through a lot of numbers. So we put dot, 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 and then we write the last element in the set. Here you have something a little different, because the 3 dots do not follow by anything there. So that means this set's going to go on forever. We have set I that contains just one element, 25. Set J contains element 0, and 0 is an element. You can make your own set by listing the ages of your 3 closest friends. This one is important. This is a set that we call an empty set. Another symbol that we use for it is this symbol, which also means empty set. So that last example here is a set that contains no elements. I want you to be very careful. The set J is not an empty set. It contains an element 0. Alright, moving on. Let's talk about when an element is or is not in a particular set. There are 2 symbols. So the first symbol here, this one, you read it as belongs to or as an element of. So you can read it as belongs to or an element of. So let's see if we can understand this. So we have set B, Sergeant, Captain, Lieutenant, Colonel, General, and we want to determine if the following statement is true or false. So just to understand, this respectively means it's not, does not belong to. So Captain, does that element belong to set B? Clearly yes, true. General does not belong to set B. Well, general is in set B. This is a false statement. Private does not belong to set B. There is no private here, so that's true, because it says does not. So we have a second example here. Set G, 2, 4, 6, etc., all the way to 30. You need to see if the following statements are true. So 2 belongs to G. You can see it right there. It's true. 8 does not belong to set G. Well, if we continue this, we know 8 is an element of G. This is actually going to be a false statement, because it's not correct. 8 does belong to G. So this is false. 17 does not belong to G. Well, we know this is only going to contain even numbers. That is certainly true. And 28 belongs to set G. Well, we don't see it, but we know it's going to be there. It's the one right before 30. So that's true as well. Okay? Alright. Let's talk about finite and infinite sets. So a set is called finite if it has a finite number of elements. Basically you can count them. Alright, it can be very large. You can have 1 trillion elements in the set, but it's just going to have to be finite. So these are some examples of finite sets. This one here, 5, 10, 15, 20, 25. This one when it's kind of long, because we have all odd numbers going from 1 to 1,000,007. So we have to put dots here, but because it does end here, this is going to be a finite set, or multiples of 3 from 6 to 300 inclusive. We also define something called cardinality of a set. We're going to talk about this. Cardinality of a set is basically the number of elements. How many elements a finite set has. So look at these sets. The one with military ranks, you have 5 elements in it, so the cardinality here is 5. A set that contains 1 element, airplane, the cardinality is 1. Here, 2, 4, 6, all the way to 30, a little more challenging because we can't quite count them the way it is given to us. Okay, so, but it is possible to, you can make a list, there's some other ways to compute that. If you actually do the math here, you will get that this set is going to have exactly 15 elements, so the cardinality here is 15. And this set here, you have 0, so it is 1 element, so the cardinality here is going to be 1. So what's an infinite set? It's obviously a set with infinite number of elements and you basically cannot count them. So here are some examples. You can always recognize it by dot 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 without anything that's going to follow it. So this is a list of perfect squares. It keeps on going. Here's a list of multiples of 5. Keeps on going. Or we can even write something like that. All positive even numbers. We know this set's going to go on forever. We do not discuss cardinality of infinite sets here. This is for college courses like topology. You don't need to apologize about that. Equal versus equivalent sets. So what is that? Sets are going to be equal if you have the same exact elements. Please remember that you do not have to have the same order of elements for the sets to be the same. So these two sets here are equal because they contain the same exact elements. These two sets here are equal because they have the same exact elements, just the order is different. These two sets here are also equal because they have the same elements, because this just describes what we have. Natural numbers less than 10, those will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're having the same exact elements here, so these two sets are equal. Okay, but be careful, whole numbers less than 100, whole numbers start at 0, so it's from 0 to 99. Natural numbers less than 100 go from 1 to 99, so there is a mismatch. These two sets are not equal. And one other thing is what's equivalent. When are sets equivalent? They need to have the same number of elements, but they do not have to have the same elements. So these two sets here, Sergeant, Captain, Lieutenant, Colonel, and General, is equivalent to the set 1, 2, 3, 4, 5, believe it or not. Why? Because we can match here's what we can do. We can make a list like that, and we can match each element from this set to each element from that set. You can basically put them in what's called direct correspondence. So it doesn't matter if it even makes any sense. You just need to be able to match them exactly, put them in direct correspondence. So these two sets are equivalent. They are not equal, of course. Alright, the ages of your 3 closest friends is equivalent to the set containing December, January, February. Again, you can put them in direct correspondence. So any two sets with the same cardinality, if the cardinality is the same, they are going to be considered equivalent. If the cardinalities are not going to be equal, then the sets cannot be equivalent. It is not possible. And also keep in mind that if two sets are equal, they are going to be equivalent automatically. But if they are equivalent, that does not mean that they have to be equal. Right here you have equivalent sets that are not equal. Same thing here. Okay? Hope this helps.